Hey everyone, so let's solve today's LeetCode POTD, last day where we can still cross. So like today is the last day of 2025, so we need to find the last day where we can still cross to 2026. So we are given a one based binary matrix where 0 represents land and 1 represents water. Now we are given integers row and col representing the number of rows and columns in the matrix respectively. Initially on day 0, the entire matrix is land. However, each day a new cell becomes flooded with water, and we are given a one base 2D array cells where cells of I will be denoting the cell which will be getting flooded with water on the ith day, and we want to find the last day that it is possible to walk from the top row. So we need to walk from the top row to bottom row. So we can start from any cell of the top row, and we need to reach any cell in the bottom row by only walking on land cell, means only walking on zeros. Okay, so in this case now we need to return this last day where it is possible to walk from the top to the bottom by walking only on land cell. So objective is simple. Objective is we need to find the largest integer k, which means representing the day index, such that a path of land cells, that means zeros, exist from row 1 to row r. And so let's see this input here. So we are given number of rows and number of columns as 2. So 2 cross 2 matrix we have, and initially all the cells are land. Now on day 1, 1 comma 1 becomes water. So this will be water. On 2 comma 1 means after day 1 we'll be able to reach, means following this path, or we can follow, means we'll be able to follow this path, or means since only 4 directions are allowed, so we'll be able to follow this path. Then if we have 2 comma 1, so we'll be again, means this becomes water, so we'll be able to reach using this path. And as soon as this cell becomes water, we'll not be able to start from the first row to reach the bottom row. Hence this was the last day when we are able to reach the bottom row. Hence the output here is simply 2. Let's see another input. So again we are given a 2 cross 2 cell. All the cells are initially land. Now at first 1 comma 1 becomes water, so we'll be able to reach using this path. Then 1 comma 2 becomes water, so obviously we'll not be able to start from the first row, and hence we'll not, means the last day that we'll be able to reach the bottom row was 1, and 1 is the output here. Okay, let's see another input. So we are given 3 cross 3 matrix. Now in day 1 this becomes water, so we are able to reach. On day 2 this becomes water, so again we are able to reach. On day 3 this becomes water, so again we are able to follow this path and reach. And as soon as, means on day 4 this becomes water, so we will not be able to reach the bottom row. Okay, so in this case the maximum day that till which we could reach the bottom row was 3, and that's why we have written 3 in this case. Okay, so what will be like the the prerequisites to solve this problem are, like, you should be aware about how normal BFS works, and then also like aware about the basics of binary search. Okay, because we'll be using it to optimize our approaches. So what will the brute force approach? The brute force approach would be to simply start from day equals to 1 and move till last day that we have. Okay, so last day that we have, we'll be moving from each days, and what we'll do, for each day we'll find out the number of, means we'll generate this matrix. Okay, so for on this day we'll generate the matrix, and now once we have the matrix, means it will be having some land cell as well as water cells. What do we want? We want to reach from any cell on the top row to any cell in the bottom row. So what you can do, you can simply start a BFS from any cell on the top row, means push all land cells and start BFS. Okay, so we can start BFS by pushing, means we can start a multi-source BFS by pushing all the land cells in the queue, and then we'll keep doing the BFS till we are able to reach the last row, which has by only following paths of zeros. Okay, so as soon as we are able to reach, we will simply return true. So we can simply, for each day we can simply write this check function whether we are able to find, means whether we are able to reach or not. Okay, in this manner, how, means what will be time complexity? Time complexity would be, since the number of days would be simply the size of the cells, because the cell, means the cell size will be denoting the maximum, means the day till which we can follow. Okay, so the day can go up to cells dot length, and it is simply row into col, and row into col can go up to 2e4. Okay, so this loop will be running for 2e4, and for generating the matrix inside again will be means running n into m, so this again is 2e4. Okay, so overall the time complexity would be, and the BFS will be taking like order of again 2e4, so it will be overall it will be 4e8. Okay, so this will be the time complexity, and obviously like it will be giving us daily in this case because it is lying towards the range of 1e9. Okay, so let's see this approach first, and then we'll try to optimize whether some optimizations exist or not. And I hope like you are able to know how BFS works. So you simply push all the land cells initially in the queue, and then simply follow the BFS using four direction arrays, and then we'll be as soon as we reach the bottom row, we'll simply return true. Okay, so let's see the approach. So what you'll do, we have the total days as this. So what do you do, we can simply start from the end day. What we can do is we can simply start from the end, and as soon as we encounter a day which is satisfying the condition, that will be the largest day. So instead of moving from 0 and moving towards the right, we could have started from the end, and then the first day that satisfies the condition, that will be the result. So we can simply iterate, and as soon as we are able to cross, we'll simply return day, else we'll return 0. Okay, now let's see this can cross function. So what we'll do, we'll first create the entire matrix of row into col by on this particular day, and then we'll apply BFS and see like whether we are able to reach the bottom row or not. So what we'll do, we have the direction matrix, as we create this direction matrix for 4 directions. So I hope like you are aware about this. So means 0 1 means 0 1 means if we are at x, so 0 1 means x doesn't exist but y increases, so means this means right movement. 0 minus 1 means left movement. Okay, 1 0 means bottom movement, and means minus 1 0 means upward movement. Okay, so this is what like this array is denoting. Now we check the can cross function. We first need to create the grid. Okay, so on this day we'll iterate through the cells and see like what cells has become water till this day. So we'll iterate for I equals to 0 till I decrease. Since R and C are 1 based, so we'll convert it into 0 based and mark the grid of RC as 1. That means 1 represents here water. We only need to traverse through zeros. Now we'll simply start the behavior. So for in the queue, we'll be pushing the cells indices ij. We have created a pair, and now we have also created a vector so that we only visit a state only once. So we'll be applying normal multi-source BFS here. So we'll simply iterate through all the columns in the first row and see like what are the values which are 0 initially. And the values which are 0 initially will be simply pushing 0 comma c, that means the 0th row and the cth column in our queue and marking it as visited. Now we iterate means start the BFS. So the current row that we have, if it is already the last row, that means we are able to reach this bottom row. So in this manner, we will simply return true. Else for this RC, we'll try going in all 4 directions because all 4 directions are allowed, and then finding out means the NX as well as NY. Now you'll see like whether they are means lying in the range, whether they are not outside the range, as well as they should be 0, as well as they should not be visited. Okay, so it should be lying in the range, as well as it should be 0, the value should be 0, and they should not be visited. So in that case, what we'll do, we'll mark it as visited and again push it in our queue. And means if this value is means this statement is never executed, that means we were never able to reach this bottom row, hence we will return simply false. Okay, so this is the overall complexity of like we see like since this day can go up to 2e4, and again this can call function will be taking what, again it will be taking here, it is taking day, and here it is taking row cross, means overall BFS will be taking row into call. Okay, so again it is taking 2e4, so obviously this will be 4e8 and will be giving us daily here. So how can we like optimize it? Can we do some optimizations to like bring the approach to something of the order of, suppose the cells dot size is 2e4, so can we do it till L means if n equals to R into C, so can we do some approach of like order of n, or like n log n will also be accepted? Okay, so can we do some optimization to solve it in this complexity? So let's try to observe like what is the means the check function that we have written, what is the criteria that it follows. Suppose we have the check function, and for this particular day, it is means it is possible. Okay, so that means it is returning true. Okay, so if it is possible for this particular day, then that means for all the days from 0 to day minus 1, it would have been possible as well. Why? Because since it was possible to move from day means at this particular day, so on day minus 1 there would be there would have been lesser water cells, means there would have been lesser water cells and hence more land cells. We can simply follow the same path that we used in this particular day in all the previous days as well. So hence, if we are able to satisfy the condition at this particular day, then all the days from 0 to day minus 1 are also true. Okay, so hence if we know that at a particular day it is true, so we'll not check on the left, we'll only check on the right. Okay, so there will be existing some max value, max day, till which it is true, and after which, as soon as, means at any point it becomes false, means it, if at this point j it becomes false, then for all further points it will be false only, because there will be more additions of water cells, and obviously since, means as soon as we added water cell in this step, we are not able to reach, so obviously we will not be able to reach, means in further days as well. Okay, so what do you observe? The check function that we have written is monotonic. First it is following this 1 1 1 1, that means it is, means true, and then it is false. Okay, and what do you want to do? We want to find the maximum day at which it is true. Okay, so we want to find the maximum day at which is true, and simply, since we know like the check function is monotonic here, so we can simply apply binary search. So what will be the search space for binary search? Search space of binary search will be, the low will be pointing to what? It will be the first day that we have, and high will be simply, high will be row into, means the cells dot size that we have. Okay, so high will be cells dot size. Now what we'll do, we'll need to find out the maximum day. So initially the max day, we can initialize it with 0. Okay, now we'll simply apply the binary search. Low is less than or equals to high. We'll apply the binary search. We'll have the mid as, to apply, means since int, means since mid is used as integer, and these values can go up to, suppose 2e4. So 2e4 plus 2e4. So this will never reach like long values. So this can, we can simply write it as low plus high by 2. If it would have been reaching means long values, we'll have written it as low plus high minus low by 2, so that we avoid all the integer overflows. I hope like you are aware about the basics of binary search. Now once we have this mid depends this particular day. So we'll check whether we can cross, means whether we can cross on this particular day or not. If we can cross on this particular mid day or not. If we can cross on this particular mid day, that means we will simply update our answer with this mid. And now we know if we are able to cross on this day, then all the previous days would have been able to cross. And since we want to maximize the last day at which we are able to cross, we'll simply move the search space towards the right, so that now we are seeing for whether it is possible at day plus 1, day plus 2 or not. Okay, so in this case what we'll do, we'll simply increase the binary search towards the right, and else we'll simply, means we know like at this mid day, this mid is lying somewhere here, so at this mid it is not possible. So we need to check for the lefter search space, so that we get some true values. Okay, so in this case what we'll do, we'll simply move the search space towards the left. Low equals to mid plus 1. Okay, so this is what we'll do, and this can cross function is still, means it will remain the same only for this mid day. We'll find out the, means the cell configuration, and then we'll apply BFS from the top row and see whether we are able to reach the bottom row or not. So can cross function will remain the same as the brute force approach, just the main function will be changing by we have applied binary search here. So this will be like overall the time complexity would be log 2 of 2e4 into the check function will be taking 2e4. Okay, so this will be getting accepted because it is like optimal till suppose it will be approximately till 2e5 I think, or since it is 2 to the power 10, so 2 to the power 10, 2 to the power 11, 2 to the power 12, 13 it will be. So yeah, means this will be order of max, it will be 1e6. Okay, so I hope like this was the means most optimal approach. Let's try to see the code as well. So this can cross function that we have written will remain the same only, because we will not be doing any means changes here, because we, for this particular day, we are able to know like whether it is possible or not. Okay, now just the main function will be changing. We have the low as 1, high equals to cell dot size, initialize the answer as 0, and the mid, we find out the mid. If we can cross at this particular mid day, then we'll update our answer and move the search space towards the right, else move the search space towards the left, and then simply return the answer. Okay, and this can cross function is the same as we discussed for the brute force approach. Okay, so I hope the approach is clear, and now we try to analyze the monotonicity of the check function, and we saw like we can apply binary search on this search space, and then we are able to simply solve this problem. Let's try to submit this code here as well. So this is the same code that we discussed. We have like the binary search approach. Let's submit it and see. uh, So yeah, it runs in 426 ms. Let's try to see the most optimal solution. They would have applied binary search as well. So as you can see, like they have applied binary search and they are doing the same thing as well. And their complexity is also same because they are also applying BFS from like the top row and doing the same. Okay. So I hope you were able to follow along with the approach discussed and were like means able to learn how do we apply multi-source BFS if you are not already aware, and then how means applying binary search was pretty easy. So if you did, make sure to like as well as subscribe. And if you yet have any doubts remaining in any of the parts discussed, then make sure to comment down. I will be happy to respond. And means Happy New Year to every one of you, since it is the last day of 2025. So yeah, thank you so much for watching.